Hello students, today let us solve some numericals from the exercise in our textbook. So page number 25, example number 19. I will read the problem. A metallic ring of mass 1 kilogram, means mass of the ring is given as 1 kilogram. So MR data is MR is equal to 1 kilogram. So it has moment of inertia 1 kilogram meter square. The moment of inertia of the ring, for ring I am writing R. So IR is equal to 1 kilogram per meter square. When rotating about one of its diameter, so the axis of rotation is the diameter of the ring. It is molten and remolded into a thin uniform disc. Suppose the ring is made up of copper and then it is melted, and now from the same material the disc is formed. From ring now disc is formed. The mass of the disc will be same and radius is also same. It is given that radius is also same, and it is asked that means M for disc, mass of the disc will be same 1 kilogram, and radius of the disc means radius of the disc means RD. RD is also same as radius of the ring. How much will its moment of inertia, it means of the disc, when rotated about its own axis? Now the ring is rotated about its diameter, then its moment of inertia is 1 kilogram per meter square. But the disc is rotated about its own axis, means for the disc the axis of rotation is perpendicular. So this is the disc, and the axis of rotation for this disc is perpendicular. Its own axis means perpendicular to its plane, and it is passing through the center of the disc. So this is the axis of rotation of the disc, and for this the value of moment of inertia is asked, means I for disc is equal to what? This is our question. Initially it was ring, and for ring the moment of inertia for ring about its own axis, for ring about its own axis. What is the moment of inertia? It is I is equal to mr square. This formula we have derived, and now this moment of inertia 1 kilogram per meter square is for the axis which is nothing but the diameter of the ring. Means now the axis of rotation is diameter instead of the own axis. So if it is own axis, then this will be the value of, this will be formula rather for calculating the moment of inertia of the ring. But now the axis of rotation is diameter, therefore we use the theorem of perpendicular axis. Ix is one axis, Iy is another axis, Iz is this one axis suppose. Then Iz is equal to Ix plus Iy. Iz is equal to Ix plus Iy. So Ix and Iy, these are moment of inertia of the ring about two perpendicular diameters. Therefore, they are the same. So it is equal to twice Ix. So twice Ix is equal to mr square. Therefore, for the diameter of the ring, the value will be mr square by 2. So, for the ring, the moment of inertia about its diameter is mr square by 2. Means this value which we have written as IR is equal to Ix is equal to mr square by 2. Now the same ring is melted and now ring is melted and disc having same radius and same mass is formed. So moment of inertia of the disc about its own axis is given by moment of inertia of the disc. For disc I am writing ID. So it is not for diameter, remember, I am writing B for the disc is equal to for its own axis mr square by 2. Now here radius is same, mass is same, and the formula for the diameter, moment of inertia about diameter and moment of inertia, this is moment of inertia of a ring about the diameter, and this is moment of inertia of the disc about its own axis. Both the formulae are the same. R is same in both the cases, M is same in both the cases for the present problem. I am talking about the present problem, and as they are same, the formulae is same. Therefore, our answer will be here from equation 1 and 2. It is clear that the moment of inertia of the disc will be also 1 kilogram per meter square for the axis of rotation passing through its center and perpendicular to its plane. That is, for its own axis, the moment of inertia will be, answer moment of inertia of the disc from 1 and 2. From 1 and 2. Mi for disc is equal to Mi for disc about its own axis is equal to Mi for ring about its diameter. Hence, answer is the moment of inertia of the disc is equal to 1 kilogram meter square. In this way, we have solved the problem number 19. Now, problem number 20. Let us now solve problem number 20, page number 25. The problem is a big dumbbell is prepared by using a uniform rod of mass 60 gram and length 20 centimeter. So, the rod is having mass of 60 gram and length of this complete length is 20 centimeter. Two identical solid spheres of mass 50 gram and radius 10 centimeter each are at two ends of the rod. Means here there is one mass and its radius is 10 centimeter, whereas the complete length of the rod is 20 centimeter, means from this end this is 10 centimeter. From this end up to the center of the rod it is 10 centimeter. And here there is another identical sphere. At the other end. And the rod is, now it is said that calculate the moment of inertia of the dumbbell when rotated about an axis passing through its center and perpendicular to the length. Now these spheres are having mass 100 gram. The total mass of the rod, that is the mass of the rod is 60 gram total mass. Then it is given that length of the rod is equal to 20 centimeter. Then mass of each sphere is 50 gram and radius of the sphere is equal to 10 centimeter. And the rod is rotating, means this dumbbell is rotating about an axis passing through the center of the rod and perpendicular to the length, like this. We have to calculate moment of inertia when axis of rotation is perpendicular to the length of the rod and it is passing through the center of the rod. Means here there will be 10 centimeter length. On the other side also 10 centimeter length will be for the rod. Now in order to calculate this moment of inertia, we should know the different formulae. That is moment of inertia of a rod about an axis passing through its center. This system is a combination of two spheres and one rod. So moment of inertia of the rod is moment of inertia of the rod about an axis passing through its center and perpendicular to its length. In the present case, the moment of inertia is ml square by 12. L is given 20 centimeter. M is also known for the rod. It is 60. So when we substitute, we can calculate the moment of inertia of the rod. Now, the system consists of two more spheres at the two ends of the rod. Therefore, for one sphere, what will be the moment of inertia about this axis of rotation? So initially, we should know the moment of inertia of a sphere about its diameter. So moment of inertia of a sphere, solid sphere, is moment of inertia of a sphere is 2 by 5 mr square. R is the radius of the sphere. So mass of the sphere into radius of the sphere, square of it. Then this is for the axis of rotation as its diameter. But now this is not the axis of rotation. The axis of rotation is at a distance of 20 centimeter from this diameter. This is the axis of rotation which is at a distance of this 10 centimeter radius of the sphere plus this. Whenever we talk about this sphere, then we here take the center, the mass is concentrated at the center of the sphere, and therefore the distance of this sphere from the axis of rotation will be naturally equal to what? It will be h is equal to here 10 plus 10 is equal to 20. Total 20. So h is here 20 because we have to use here the theorem of parallel axis. For this axis, we know the moment of inertia of the sphere. It is equal to 2 by 5 mr square, and moment of inertia about the parallel axis to it will be obtained by this formula. IO is equal to IC plus MH square. We are going to calculate IO, that is for an axis parallel to the diameter of the sphere. Means if I have to write down for this situation the moment of inertia of the sphere, then I must add mh square to this. M is mass of the sphere, so ms, mass of the sphere. H is, now we have calculated, it is 20 centimeter. This is r plus L by 2. R of what? R of the sphere plus L by 2 of the rod. So in this way we get the formula for now the moment of inertia of the sphere about this axis passing through center of the rod. Hence this is the moment of inertia of the one sphere, and this system consists of two spheres which are equidistant from the axis of rotation. So this moment of inertia of one sphere plus moment of inertia of the other sphere plus this moment of inertia of the rod will give us moment of inertia of the dumbbell. So moment of inertia of the dumbbell I, let I be the moment of inertia of the dumbbell. So let us write that line. I have less space, hence I am not writing that sentence here. The moment of inertia of the complete system or dumbbell is given by I. So I is equal to ml square by 12 plus 2 times, because there are two spheres at two ends of the rod, I will write 2 times 2 by 5 ms rs square plus mh square means ms rs plus lr by 2 mh square. Therefore, here square of it. Here also square of it. So, this bracket is to be completed. Now, we shall substitute the value. Here it is mass of rod. Here also length of rod is it. So, therefore, IR is equal to, for rod, MR LR square by 12 for this present situation. So, mass of the rod is 60 gram. So, I will write 60. All the things are in CGS system. So, there is no need to convert the units. So, 60 into L square. L is length of the rod. It is 20. So, 20 square divided by 12. So, here 12 5s are 60 plus 2 times 2 by 5 is as it is. MS, mass of each sphere, is 50 grams plus RS, radius of the sphere, we know it is 10 centimeter. So, 10 square means 100. So, may I write directly here 100. RS square is 100 plus MS, mass of the sphere, is again 50 gram. RS is 10 and LR is 20, but we want 20 by 2, LR by 2 means 10 plus 10 means 20 square into 20 square. So, bracket I must complete. So, this is equal to, this is equal to 12 5s are 60 means 5 into square of 20 is 400 plus 2 times, here 5 tens are 50 and multiplied by 100 will give us 1000, multiplied by 2 means 2000 plus 50 into square of 20 is 400. So, we have arrived up to this step. Now, it is equal to 5 4s are 20 and 2 more zeros here means 2000 plus 2 times 2000 plus 5 4s are 20 and 3 more zeros means 20,000. 20,000 plus 2,000 is equal to 22,000 and we have to multiply it by 2 plus 2,000. So, 2,000 plus 22 multiplied by 2 means 44 and 3 zeros, here also 3 zeros, that is 44,000. 44,000 plus 2,000 is equal to 46,000, and as it is moment of inertia and all units are in CGS system, the answer comes out to be, or the unit of the answer is gram centimeter square. Therefore, the answer for the moment of inertia of the dumbbell about an axis perpendicular to its length. This is a dumbbell and axis of rotation is passing through the center of the dumbbell and it is perpendicular to its length. For that, the moment of inertia comes out to be 46,000 gram centimeter square. So this is the answer of our question or the problem.